Alright, geometric probability 11.7. Remember that probability is the likelihood. It's a measure of likelihood. This is a little bit subjective, but we're doing geometric, which is talking about the way that we approach things geometrically in probability. Alright, segments, easy definition. An example of probability that k, some point k, let's call this k. The probability that this point is somewhere on this segment, CD, if it has to be on the entire segment, would just simply be the length of CD divided by the length of AB. You can think of this as the part over the whole, just like calculating fractions. The whole is AB, the part is CD. So let's go ahead and do a calculation. Let's say find the probability that the point chosen at random on PQ is on RS. All we have to do is the part over the whole. Part over the whole. Well, the part is the distance from PQ. Starting at P, we need to count 2Q. 1, we don't start counting until we get to the first step. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 over the total, which is RS. Point on PQ, excuse me. The total is let me go ahead and erase this. The total is PQ, but we're looking for the small part, which is RS, which that's probably a common mistake. So 10 is the total, RS is the part. Starting at R, 1, 2, 3, 4, 5, 6. 6 over 10, which reduces to 3 over 5. If we're looking for this as a percentage, you just convert it to percents like you did in middle school, 60%. Alright, go ahead and pause the video, try these 4 problems. I'm going to omit number 5. All we're doing each time is just finding the part over the total being PQ. So I get the part, which is 1 divided by 10, and I get 10%, 50%, 40%, and 70% chance. Alright, geometric probability extended from lengths to areas. It's the same deal. It's still just the part over the whole if we're talking about area. So notice it's just saying the area of M over the area of J tells us the probability that something landing on J will end up in M. Part over whole. Alright, say we've got this target. This word problem tells us that the diameter of the red circle is 16 centimeters, and that's the diameter of red. That's equal to 16 centimeters. And the diameter of the large one is 80 centimeters, the total target. So diameter of target is 80 centimeters. It says what's the probability that it lands in the red circle if it lands on the target. So we need to find the area of the part divided by the area of the whole. All we do is just find our values we need for the formula. Notice this is the area of a circle, so pi r. R is half the diameter, so it's 8 squared. And then pi r squared, the whole diameter is 80. That means that half of it is 40. And you just simplify this. Notice the pi's cancel. That means we've down to 8 squared over 40 squared, which I get to be 4%. There's a 4% chance that something landing on this target in some way will actually land on this red zone. Alright, if you had to estimate a value like this, it says what's the probability that something landing either in the field or the woods lands on the field. All you need to do is find the area of the field, and you're going to have to approximate it, noticing that this is a rectangle, pretty easy to calculate. And we need to find the area of this by approximation as well, so you can just break this up into simple figures. You can call these maybe a triangle, and another triangle over here, and a triangle here, maybe here, yeah. Find a triangle, break those down into simple parts. You're going to do the area of the field divided by the area of the total. That's all you do there. I chose to do guided practice number 6. It references the target from previous problem. Go ahead and pause the video, see if you get the same answer I do. Well, I believe the textbook made a slight mistake because they said this is 8 centimeters wide, which meant this is 8, 8, 8, and 8. 8 times 4 is 32 plus that 4 from the original is 36. So instead of having a radius of 40 like example number 3, instead of it being 40 or 80 as the diameter, now it's 36. Whatever. I just worked with it as if that were the problem. And this is a little tricky, so see if you can follow what I'm about to say. Now, it's the area of the part. Notice I'm calling this black ring 1, and this is number 2. Yes, I have the 36 squared. That's the total radius. This is the area of the total circle. Minus the 28 squared. Well, that's the 8 plus the 8 plus the 8 plus the 4. That's this circle. So that gives me the first black ring. Then, to get ring number 2, it's the 20 squared. 20 squared is this plus that. And that's the first circle. Then we have 12 squared, which is just the 8 and the 4. And that gives me ring number 2. The total is 36 being the radius of pi r squared. I just simplified this. Sorry about the bell. And it becomes 59%. Alright, I've picked a few problems from the exercises to go through with you. You're going to do the odds in class, or I'd like for you to do them in class. We're going to do the evens right now. So it says find the probability that a randomly chosen point in the figure lies in the shaded region. So notice we need to find the area of the part and divide by the area of the total. Well, the total in this case is the area of the circle. The part in this case is the area of the circle minus the area of the square. If you may need to pause the video and reason that out with me. Alright, so now we just need our pieces to plug into that. Our radius is 2, so our circle's easy to find. Now, if this is 2 and this is root 2, this is a 45, 45, 90 triangle, which makes this root 2. And if that's root 2, this is root 2, which means the side length is 2 root 2. Just using 45, 45, 90 triangles. And then I just plug in my values. Pi 2 squared, that goes on top and it goes on bottom, minus the square of 2 root 2 squared. Some of you might not know what I'm about to do with the arithmetic, so you might need to pause and review this part that I'm about to say. This becomes 4 pi because 2 squared is 4. That's 4 pi on the bottom as well. These cannot cancel. Common mistake because of this subtraction. You cannot do that. But we still have the 2 root 2 squared, which becomes 4 times 2, which becomes 8. 4 pi minus 8 over 4 pi. Now we're looking for a ratio here, or a percentage, so we can just type it in just like it is. It's best if we press alpha y equals numerator over denominator when typing this in, so we don't have to worry about our parentheses. Divided by 4 pi, I get this to be 36.3%. Alright, let's go to I'm going to do the other even. The other even, remember we're doing the area of the part divided by the area of the total to get the probability that an object will land in the shaded region. Notice the top is a trapezoid, so it's the area of a trapezoid. As trapeze minus the area of the rectangle, that gives us the area of the shaded region divided by the area of the trapezoid. So I just need to plug in the values that I have from the visual. Notice everything we need for the formula is given to us. So the area of the trapezoid is 1/2. In fact, in this case, you might find it beneficial to go ahead and just simplify this and simplify the rectangle before we even plug it into this formula here. Area of a trapezoid is 1/2 times height, which is 5, times the bases added together. It's just 28. 28 divided by 2 is 14. 14 times 5 is 70. Alright, so that's the area of a trapezoid. Area of the rectangle is 8 times 5, which is simply 40. And then the area of the trapezoid minus the area of the rectangle is 30. Area of the trapezoid is 70. So we have 3/7. 3/7 as a decimal, or as a percentage rather, is 43 or 42.9. Let's do 42.9. Let me erase that. And that is the percentage. Got a few more problems picked out. I'm going to do the evens with you. It says find the probability that a randomly chosen point in the figure lies in the shaded region. So we just need to find the area of the shaded and divide by the area of the total, or area of the part divided by the area of the total. Notice the area of the part is the area of the triangle. Notice the area of the total is the area of the triangle plus the area of the, let's do try for the trapezoid. So we just need to plug in our values and simplify. Area of the triangle. Now, to find the area of the triangle, we're going to have to find this other side over here. Notice this is 5 and this is 3, which means this is 4. So it's just 3 times 4 divided by 2. Let's not worry about simplifying that for a second. Area of the trapezoid is 1/2 base times the sum of the 1/2 times the height times the sum of the bases. 5 plus 7 is 12. Now it just comes down to simplifying. 3 times 4 divided by 2 is 12 divided by 2, which is 6. 12 divided by 2, or 12 times 1/2 is 6, times 3 is 18. And that is 1/3, which is 33.3%. There is a 33.3% chance that a point will land in that shaded region. Number 22, we're looking for the shaded region over the total. So that's just the part, which is, we'll just call it a piece for a second. Actually, let's go ahead and reason it out geometrically before we continue. So notice it's the area of the sector minus the area of the triangle that goes with that sector divided by the area of the circle. Area of the sector, notice this is 90 degrees, which means this sector is a quarter of the circle. And the radius of that circle, we do not know just yet. We know this is 8 right here, and if this is 90, this splits up into 2 congruent triangles. That means this is 45. If that's 45, that means this is 8, and the radius is 8 root 2. So the radius is 8 root 2, and that's going to be squared. Now the triangle is 8 root 2 times 8 root 2 because it's the base times the height, 8 root 2. That's going to be squared. All divided by the area of the circle, 8 root 2 squared times pi, because it's pi r squared. Alright, now it's just coming down to arithmetic, simplifying this. I find a lot of students get confused with this, so I would suggest if you do not understand what I'm about to do, please go back and look it over. So 8 squared, by the way, both of these get squared. 8 squared is 64, 2 squared, square root of 2 squared is 2. Let's just do parentheses, and that means we have the same thing over here, 64 times 2, all divided by pi times 64 times 2. Still simplifying, 64 times 2 divided by 4, let's just go ahead and pull out the calculator, is 32. So the top is 32 pi minus 64 times 2, which is 128. I'm just simplifying as I go, 128 pi. Alright, at this point I'm going to pull out the calculator and just type it in, because I don't think there's much more we can do with simplifying. We can pull out a 2 or another common factor, but it's not really that big a deal. I got a little problem. Let's see if I can find my mistake. Yeah, I had a negative answer, which is not reasonable, but that happens to students sometimes, so it's probably good that you saw me go through it in the video. Notice it's base times height divided by 2 for the area of a triangle. It means this is divided by 2, which means that is 64, not 128. So this right here is 64. Type that in, you get 9.1%. That's it for the video.